Dear colleagues, I hope that you enjoyed the presentations of the last 2 hours of this breakout session, and I hope that you can actually agree with me on the following. I think we have achieved our purposes. And what we were set out to do is we wanted to know whether the DC grid protection was technically feasible, whether the equipment was ready, and whether we could go beyond academic research and provide the evidence that DC grid protection is indeed ready for the market and interoperable. And we also figured out what are the consequences on the total CVA. So I hope that you agree with me in the following key takeaways that we have formulated for this work package or for this task that we have. So we believe that we have de-risked the HVDC grid protection through the development of a consistent set of requirements, analysis methods, or analysis models and tools, and prototype equipment. The work package has proposed a vocabulary and functional requirements for fault clearing strategies for HVDC grids, as their scope goes beyond the traditional scope of power system protection. Detailed protection sequences, including fault detection, protective actions, and control actions, have been proposed for each of the fault clearing strategies, clearly showing that protection and control are fundamentally interlinked. The technical key performance indicators to assess the performance of a given strategy have been proposed. The assessment of protection philosophy showed that several philosophies could serve as a viable technical solution to DC site protection. And we developed not only an academic, flexible, and multi-purpose protection IED, also an industrial-grade prototype has been developed within the project. And we have used them to demonstrate the principles of fast-acting protective relaying algorithm. The academic prototype is open source. That's nice. The test procedures to evaluate the performance of HVDC IEDs have been developed, and a risk-based cost-benefit analysis methodology is developed, which allows to evaluate the cost-effectiveness of different protection strategies, considering AC and DC site reliability-based operational expenses. We know that DC grid protection strategies could impact the frequency stability and the transient stability of the AC transmission systems surrounding the DC network due to a temporary outage or a disturbance of the DC power flow, which can reach several gigawatts for hundreds of milliseconds. A precise assessment of the AC stability issues requires the detailed data of the AC system and its dynamics. We found that no single protection strategy outperforms all the others on all possible future grids, both on a technical and an economic level. However, we have developed all the tools necessary to evaluate them within this project. So we have allowed you to perform the research to make sure that the correct and most beneficial protection algorithm is there. And while DC grid protection is comparatively more expensive than AC protection, it is not blocking development. And with that, I thank you for your attention. I hope you enjoyed the outcomes that we have to show. Unfortunately, this is just a glimpse of all the work that we did in the last years, and I would refer to you to all our publications and deliverables that we have made during this 4 years. And of course, if there are any questions, please do not hesitate to ask.